Hey guys, Mr. Milton here. Today we're looking at angle measures and segment length notes. At the end of this video, you should be able to find angle measures within circles, and you should be able to find segment lengths within circles. Okay. So let's look. It says the measurement angle formed by two lines that intersect inside a circle is half the sum of the measures of the intercepted arcs. So as we look at angle 1 here, you'll notice that the intercepted arcs are here at X and then here at Y. So we could write that angle as measure of angle 1 equals 1/2 of the sum of X and Y. Okay. If our lines intersect outside a circle, then it is half of the difference of the measures of the intercepted arcs. In all three of these examples here, whether it's chords that meet on the outside, a tangent and a chord, or two tangents, we can find that angle by doing 1/2 X minus Y. Okay, and notice that in all these cases, X was the largest angle. It'll never be a negative angle measure, so make sure that you are choosing the larger number to go first. All right, so let's run into some of these example problems then. It says find the measures of the indicated angles and arcs. So here we have this angle X. Let me zoom in and make it a little bit more space for me to work on. Okay. So here it's inside of our circle. So X should be the sum, or half of the sum of the intercepted arcs. So we see one of those intercepted arcs is 46. The other is 90. And so when we add those two together, that gives us 136. So half of 136 should give us 68. Okay, not too bad. All right, number 2. We're trying to find Z, but remember that our angle is what we know is the half of the arcs. So we already know our angle. So I know that a lot of people will mistakenly put Z out here as what needs to be in the formula, but our angle is what needs to be out here. So it's 20 equals half, because it's outside of our circle, it's going to be the difference of the two arcs that's intercepted. One of those arcs being 95, and visibly the smaller arc being Z. Okay, so now as we set this up, I can multiply both sides by 2 to get rid of my fraction. And so I get 40 equals 95 minus Z. I'll subtract 95 from both sides. And that gives me negative 55 equals negative Z. Okay, so getting Z all the way by itself, Z must equal 55. All right, so for this last problem here, we're given an outside angle of 50. Remember that our equations that our theorems that we have told us that an angle on the outside is going to be half of the difference between the arcs that it intercepts. Okay, so here they're asking us for TH. We can write that a bunch of different ways, but the only information they gave us was that our WH is 100. Okay, so what I'm going to do, get a little bit creative in how we're labeling our sides. I want to find this bigger side. I'm going to call this X. Okay, and since this is 100, I know that altogether we should have 360. Okay, so that means the unlabeled portion, or entire rest of this, the red, should be 260. Okay, so if I call it TWX, then this would be the rest of 260 after we take away X. So 50 equals 1/2 the larger arc, 260 minus X, subtract the smaller arc. So what we have is 50 equals 1/2 260 minus 2x. Okay, now we're solving for x. I'm going to multiply both sides by 2. And that should get rid of that half. So I have 260 minus 2x here. Subtract 260 from both sides. That gives me negative 160. Divide by negative 2. And we find that x equals 80. Okay, remember they didn't ask us for x. They didn't really have x. We used x to label it. So they're talking about the arc TH. Okay, it has to go from here to here. And so 2h we label with 260. So 260 minus x. And that should give us 180. So the measure of arc TH, measure of arc, is 180 degrees. All right, so that's angles. Let's flip to the next page and look at segments inside of a circle. All right, so for segment lengths, it says for a given point and circle, the product of the length of 2 segments from the point to the circle is constant. Okay, and so 2 segments. 2, as we look at that, it's broken into 2 pieces. Okay, so here are our 3 situations. If the point is inside the circle, the point referred to in this theorem is point P in this example. For the pink line, the lengths of the segment from the point to the circle are represented by A and B. For the blue line, they are represented by C and D. And so what they're saying for this theorem is that A times B should equal C times D. Okay. Our second situation happens if our point is outside of the circle and one line is tangent. Okay. For the pink line, the lengths of the segment from the point to the circle are y and y plus z. Okay, and so what we're thinking of is from here to here is y. From the other point to here, how we label that, we call that y plus z. Okay, and for the blue line, it's just t and t, or t and t, not t and t. Okay, and so therefore we could say t times t, that's t squared, y times y plus z. Just write it like that for right now. Okay, and source 3 is that both lines are the point is outside of the circle and no lines are tangent. So I'm going to say both lines aren't tangent, but it's not good English. Okay, so for the pink line, the lengths of the segments from the point to the circle. So from the point to the circle, y. From the point to the circle, is y plus z. Okay, as we look at the other one, we have w and all the way over here, w plus x. And so we can say y times y plus z equals w times w plus x. Okay, so we have these situations. Let's look at finding these variables. So for our first example, you can reference those notes. You should be able to reference these situations to see what's happening. For number 1, we're looking at that third situation where we have the point outside and no tangent lines. So as we can look at this, we can say, okay, one line, 6 to 6 plus 8, 14. 6 times 14 should equal, look at the other one, 7 times y plus 7. Okay, and so here's our equation. So as we multiply this, 6 times 14 gives us 84. 7y plus 49. So we distribute there. Subtract 49 from both sides. and we get 35 equals 7y. Divide by 7, we find that y is 5. Number 2, probably the easier of the situations here. If we're looking at this point, from the circle to the point is x. From the circle to the point is 4.8. So 4.8 times x should equal, from the circle to the point is 7. Circle to the point here is 7. So 4.8x equals 49. To find x, we divide both sides by 4.8. And so we get x to be 10.2. And then finally, this should be situation number 2 if you're keeping track of looking at all those examples. We have point to the circle, which is 8. Point to the other part of the circle, 16 plus 8, or 24. And then the other one we have this z, and z again, so z squared. So as we multiply that, that gives us 192 equals z squared. Take the square root, and the square root of 192. Square root of that gives us 13.9. Okay. Or if we wanted to, it'd be like 3, 64, 8 and 8, 8 radical 3. They asked us to put it in simplest radical form. Okay. Which they didn't, but might as well review that a little bit. Okay. All right, so there are our notes for angle measures and segment length. See ya.